Good afternoon, ma'am. Good afternoon, sir. Good afternoon, everybody. I am Brigadier Das, working in Department of Defense Production and currently pursuing my PhD at Single College, Pune. My presentation paper today is about electronic component obsolescence mitigation techniques. So, to be more precise, the title as shown on the slide is Addressing Electronic Component Obsolescence through Various Approaches, and the comparison of all the approaches result. I plan to present my paper as shown on the view file: introduction, followed by what is actually electronic component obsolescence, then how what all methodology I am proposing in the paper or are available, and whatever I have done, then results thereof and comparison. So before I show the reference, I will be concluding. Now coming to electronics obsolescence as such. You see, we generally talk about shelf life, but in case of electronic components, electronic assemblies, the more prominent it is upgradation. So the previous version life goes off, and that becomes a very big issue. That's why main causes of such things are rapid changes in safety requirement, environmental legislation, material technology, uneconomical production requirement, changing electronic market trends, then limited spare availability, etc., etc. So these are the main causes which make anything obsolescent and finally obsolete. So this is a fast growing problem, not understood generally and not well managed also. It can cause serious operational availability problems. So problem is often addressed in a reactive mode, means somebody addresses is when problem already crops up. So I will be talking about on my paper how to address it in a preemptive manner. So same thing I have tried to the ongoing trend for electronic industry for the product manufacturing and system design is changing at very rapid pace. And the AI technology provides significant techniques in this. So major issues on the hardware and software has challenged to develop optimal obsolescence mitigation with the help of machine learning, which I will be talking about various methods that are in the machine learning. First of all, I'll be talking about the component lifestyle. As you can see the diagram, the availability versus time. When it is in developmental phase, the availability keeps on increasing. After the development gets finalized, then availability becomes constant, means sale, purchase, etc. become constant. And as you see the graph going horizontally, the yellow portion where some new version, new design is coming, and the current one starts becoming obsolescent, finally turning into obsolete, shown by the red triangle. So what we are concerned here with is the zone, obsolescent zone, where this predictability has to be made, for which various machine learning approaches I have just talked about, which I will go in detail in next slide. But in next slide, I will show you how upgradation is hitting a component market. Like if you see, there are two boxes right side. One is military system device. The down below box is about commercial items. So for military item, what one author has shown, in 1986, over a period of 30 years, 2 upgradation took place, whereas in 1996, 4 upgradation takes place, say, every 7.5 years. However, in the similar period for 30 years, 6 upgradation took place. So one upgradation making the previous version obsolescent. This is the problem that I'm going to talk in my subsequent slides. Now, when we see the same thing, I've tried to show by a graph. As you can see, the rightmost part when item becomes obsolescent. That is the reason of the graph we are more concerned in, and how the same can be predicted. The mathematical formula for the same goes like this. So next is why obsolescence takes place. It is first due to technological innovation, then accessibility or resource scarcity, then commercial feasibility, then environmental changes. But what I will be concentrating on is the technological innovation, which renders the current going on one obsolescent, and how to predict it, how to forecast its usable shelf life, not exact shelf life when it will become dead, not like that. It will be usefully dead. So that is the predictability I'll be talking about. So how the same is addressed? In a reactive manner, in a proactive manner. Reactive short term and long term. Proactive, you have to do forecasting through machine learning. And what to address? Obsolescence risk. Then life cycle forecasting. So what are the methods? Earlier the methods were statistical approaches. Now in the era of artificial intelligence, machine learning techniques are taking on. So in the machine learning techniques, before machine learning techniques, I will just go through the literatures that I have gone through in literature review. I will not be wasting much time over this, because there are so many things to talk about. Suffice to say, all these literature review are talking about mostly about statistical analysis approach, then machine learning approach of primitive methods, but they are not probably giving so much accurate as I am proposing in my paper. So much so about literature review. There are so many gaps, research gap, which I have not purposely brought out here, because I will be straightway talking about the methodology. So methodology is inventory prediction model preparation, then analyzing the data, that is data mining, and analyze the predictive models with all these machine learning algorithm. Same thing I have just explained is in this slide. Historical data, then data mining, then analyzing the same, and combining all this in order to do the predictive analysis. So various techniques in order to address this issue is first linear regression, then neural network regression, Bayesian regression, decision tree or data forest, then support vector machine. I will be talking more about support vector machine approach to address the issue. Now, linear regression is nothing but assumes a linear relationship between input and output, and the equation is known as regression line. The data in data tree, which is random forest, is a combination of data tree. So in data tree, it works by building a model of the data points, either by splitting them into different categories or by assigning them weights. Weight is the keyword here. In random forest, these are combination of decision tree. They use multiple decision trees to make a prediction. Then Bayesian regression is the basic Bayesian theorem to estimate the probability of a given outcome, and support vector machine, where the inputs are plotted and a hyperplane is found to maximize the margin between the data points. These are some mathematical equation of linear regression. Here we see y is the output, w is the weight, x is the input, e is the error. So it is summation of that. It is the next version of the same is neural network, where perceptron is used to calculate the combination of input from a vector of real valued inputs. Here, the weights are calculated fresh by giving, as you can see, equation number 6, delta wi, which is nothing but the new weight, and new weight is calculated by multiplying learning rate by mean square error multiplied by the input, and this data correction gives weight correction gives new weight in order to find out accuracy. Now coming to Bayesian regression, this is the equation. We know the basic Bayesian equation, likelihood, prior, posterior, and the evidence. Based on that, error and probability function is calculated. Here, alpha is the precision of the prior. Now coming to support vector machine. Support vector machine is the regression is a set of linear function. It defines the regression estimation with the help of a term called insensitive loss function, and this minimizes the risk based on a structural risk minimization principle. This is the basic mathematical equation of support vector machine approach. Here we can see RSVM it is nothing but the imperial risk. Risk means you are forecasting. How accurate is the forecasting is given by this term. So the term is C1 by n something plus 1 by 2 omega square. It is the C where we are much more concerned, because this is the regularization constant, which depends upon Lagrange multipliers. And so when in ML techniques, machine learning techniques, the training is done, the Lagrange multipliers are chosen such a way while training using the C. C has got a constant value, and it can be expressed in the manner shown on the slide, linear function as well as exponential function. Here, the A is the slope of the line hyperplane. So A can have value from 0 to infinity, that is the range. As it increases, as this increases, the accuracy increases, but then saturation also comes on. What I will be talking about, okay, when C, if I put two values, generally it is constant in order to arrive the accuracy. If I put two values, that first value is for half the data set, and for next data set, second value, then I have found in my algorithm accuracy mode. So what I talked about is the find out the error, two error. First is RMSE, as you can see on the slide. Second is MAE, that is mean absolute error. And for all the purposes, these two errors will be calculated, where error is the minimum, accuracy is maximum, so prediction will be more accurate. So basically the methodology is this data collection, then data process, split data into input output, then regression over various techniques that I just talked about, and then calculate the accuracy. Same thing what I have depicted in the table or in the flow chart is depicted on the slide. Now, in order to train the data, I got the data from a local market at Pune. It shows for 5 years sale of 5 computer items, that is equal, shown by 0157, then e-switch, then microcontroller 16-bit, then optocoupler, then 8-bit. There are 5 items, and the sale in quantity 5 years have been given. So the same thing represented here graphically. Now these data have been all 5 items have been coded like this, 000 to 100, in order to fit it into the algorithm and the code and find out the accuracy. So after mapping this onto the algorithm, you see the result. Result is, first column is algorithm, where there are linear regression, ILR, DT is data tree, CCOM is SVM based component obsolescence mitigation, DR is the Bayesian regression. The column item 5 item in each. Then next is combined training data, where accuracy error has been shown, and last column is the column separate for each component. So you can see for CCOM, that is support vector, in my paper, the error is the least, so this will give the better accuracy. So RMSE means root mean square error. This is the training data. Now same thing shown graphically. You can see the SVM model. error has come the least. Obviously, accuracy is more, as the error of SVM is found to be the least, hence most accurate. Same result for testing for combined training data as well as for separate training data. Here also I can see, as we can see, that SVM model has the least error, so obviously maximum accuracy. Same thing shown here as bar chart. The SVM shows the least error. This is mean absolute error, more or less same result as it was in the case of root mean square error. Same thing shown graphically here. Then it is for testing data, same shown as bar chart. Now coming to the discussion part, as you can see how all the parameters have been integrated over the model, then how all these have been compared, and the models with highest evidence and typically those with intermediate complexity or models which is just high enough to adequately explain the facts of obsolescence. Here, crucial theoretical information has been covered from linear regression to Bayesian regression, finally to SVM. First step was data collection, then was all those computer products that I just talked about. Now coming to the conclusion, the risk of obsolescence and the product life cycle can be predicted using a variety of techniques that I have just talked about. The goal of this paper was to develop a machine learning based system. Innovative approach specifically enables forecasting. It has to be as accurate as it can be. So just to conclude it like this, the SVM based model, which I named in my paper SVM based electronic component obsolescence mitigation, for all these 5 items, that point number 3 as I shown. So this model has shown the most accurate result. So so much so about my presentation. Now future scope, further methods can be in machine learning only through deep learning can be found out, and same can be compared with the accuracy that I have found. Also, this forecasting experiment does not take into account the external or environmental variable like promotions, discount, which has the direct bearing on sale. And so the data that we collect in order to do the modeling may affect the result. So these factors have not been taken. While making future models, such things can be considered. So this was about my presentation. The references are like this. So any question anybody would like to ask, I'll be happy if I can answer the same.
Is there any question who would like to ask from sir? I think there is no question from audience side. So thank you, sir, for presentation of your.
So now I'm going to put.
Thank you, ma'am. Thank you for patient hearing and giving me a chance to present my paper. Thank you, ma'am. Thank you.
Thank you, Ajay Das, sir. Being a brigadier in the, you are presenting a paper, coming back to the research, the passion for research, we are very well appreciated to you. And thank you very much, sir, joining.
Thank you, sir. Thank you, sir.
Thank you. Okay, thank you.